name's Adam. I work at Disqus, and my Twitter handle is, I've got a laser pointer. North is up, if you find this interesting. First, a common misconception that I get correct. You say it like, let's discuss, not discus. Very common misconception, however, no longer. And I can just say this up front. We are hiring, and I think that I'm going to talk about some very interesting things. And we have lots more interesting things, so if anything like piques your interest, hey, we will pay you to do that. So first, if I ask you to raise your hands, how many people will raise their hands? All right. That was like 80%. Okay, pretty good. So how many people know what Disqus actually does? Like, oh, wow, like all of you. This is great. Sweet. Skip this slide. This is just a product. Like, this is a picture of it like a year ago. I have not updated these slides. And yeah, so it's comments. And really, we see it as building community because we allow websites to manage their community and grow it by interacting with it, as well as giving spam and other moderation tools. And then also this larger community of people that use our product across the internet. It's allowing them to friend and follow semantics. So we're pretty big. This is from February, and we've crossed 1 billion unique visitors per month. We have lots of visits. All these numbers are just way bigger now. And we also have systems that have very high concurrency. So we've got lots of visitors, but they don't line up all nicely, one in a row. Like, they want to come at the same time. Like, what's up with that? And so we also have super high concurrency along with high aggregate numbers. So what technologies do we use? Mostly Python. There's definitely JavaScript. That's how you get it on a web page. But I'm here to talk mostly about the Python. We love Python a lot. It's really great. Why do we love it? Well, it's really fast to develop with. People argue about the actual CPU speed. We'll let them argue. But I think it's undisputed that Python gets out of your way. There's no, you look at the Java hello world, you look at the Python hello world. One of those is 1 line, and one of those is like 15 lines. It's got a great community. Like, look at this room. It's full of people. We love it because there's a great community around it. And us, along with all of you, release awesome library packages that it's super easy to just use. Like, I didn't write simple JSON, someone else did. And it's awesome, I use it all the time. It's also just like a super active language. We're not even keeping up with the head of the language. We're just finishing our transition to 2.7. But I love it that other people are out there thinking of what's next and what are the problems that I'm going to be facing next year. And keeping on charging ahead with that. And like also PyPy, there's multiple implementations of it that are super active. So those are really great. But most importantly, we've been doing it for like 6 years. So we've kind of got our loop of how we develop down really pat. How do we do that? Well, this is like the most, one of my most frequently asked questions. It's not about any of the technologies. It's like, how do you actually do work? Well, slide. So the first thing we do is we don't actually commit code. We diff the code. So we use this tool that out of Facebook called Fabricator. So we make a diff of our changes, and we upload them to this Fabricator thing. It's a nice little command line tool that does this all. People review that as well as a computer. A computer also runs the test, so that's Jenkins. And then once both of those, once the humans and the test runner agree that it's good code, we do our git push, and then we wait. So we do basically continuous deployment, but that basically is like 1 to like 8 times a day. 8 on like a super hot day, but usually because we had to fix something, not because we were like super productive. So, we are moving to try to deploy every commit for reasons I'm going to talk about later. But right now, it's basically daily. So just a breakdown of what that Python is. It's almost entirely Django. So 2 years ago, that was like 95% Django. Now that's like maybe 70% Django. And I totally made those numbers up, but they're roughly accurate. So what is in that gap? Like, so we've like got this, I wanted to do pie charts, but I couldn't figure out how to use numbers. So I must be really stupid because I couldn't use an Apple product. But file a bug. Thank you, Cindy. Okay. So what's in that growing gap? Let's talk about that. But first, just a little bit more detail about, let's skip the slide. So how do we, like, what's a little bit more detail about that workflow and why are there some pain points in it? You know, so again, our stack is almost fairly Django and Celery, and we put that on top of Postgres and Rabbit, and every one of those technologies on the top, we're just like pushing to the max. We've got like this 300 gig of RAM, gig RAM master database that's running Postgres, and that's just got like tons of read slaves. Like, we're super read heavy. So we just got this giant, and it's got like 32 processors in it that are all like super big processors. They're probably Xeons or something, or whatever Intel is selling us now. It's crazy. And same with the Rabbit machines, and they're all just like pushed to the limit. And so that's one of the reasons for the talk. Like, what are other options there? So again, we roll up commits for deploy. What are potential problems with that? Well, it's a roll up. So I'm perfect, of course, but my coworkers might not be. So sometimes they have a bug and we have to revert. My perfect code, which was going to increase revenue for the company, but now it doesn't go out till tomorrow. So revenue doesn't go up until tomorrow. But sometimes I'm less than perfect, and this is true. I left a pdb.setTrace that got through code review, and it didn't even just like break, it just like stopped. And so yeah, so sometimes things do get through. So you know, we have super high scrutiny in that code review, but there's like, Disqus it's a relatively small engineering organization for that over 1 billion hits a month, uniques a month. We have 17 engineers that are committing to this code base right now. And, but that's still a lot of commits that we're all generating a day. So we've got a pretty high volume of code review. So round trip time for a review can be up to 24 hours. And then also there's just like legacy code. We still support API version 1.0, and that thing's the worst. Stop using it if you're using it so we can delete it. So what are problems that just don't fit into that stack of Django and Celery on top of Postgres and Rabbit? Well, super high concurrency problems. So what's super high concurrency? I previously wrote our real-time system, and that was seen between 2 and 5 million concurrent users, depending on the mood of the internet and whether or not a new pope was being selected at the time. Or other, like the Boston bombings was just through the roof. Like, everyone was on the internet at the same time, and they all went to CNN. And yeah, so that's crazy. So very high concurrency problems. Also, we want to compartmentalize risk. So sometimes you have a task that is very volatile and prone to failure. Or you have a task that's very sensitive to failure. It's like, oh, we made it. It's going to make us tons of money. But if you like blow on it, it will just like fall over. So those are both reasons to try and do some sort of isolation for that code. Sometimes we need speed. Like, sometimes Python is not fast enough, and we have super well-traveled paths, code paths. They're like, let's optimize this, and let's put it in a language that's just only fast, but hard to read. But sometimes you just want to move fast as an individual. You're like, oh man, these guys are solving really hard problems, and I want to solve this new problem that's really small. So I need to move quicker than those other guys are. Also fun. What is the point of all of this if we're not having fun? So sometimes you just need to like explore new options and technologies. So what did we play with? Well, the first thing we started playing with was Nginx. Real-time was one of our earlier products that was using Nginx as a core. And it was basically Nginx just serving Python processes. But as we started exploring that ecosystem, we really started seeing a lot of cool stuff, like Nginx modules. We found there were Nginx modules that could just wholesale replace banks of servers. So one specifically that I talk about in this, I love this laser pointer, in this talk, from PyCon this last year. I talk about how we use the Nginx push stream module to, I think that's like one Nginx box could replace like 15 gunicorn-based things that were basically doing the exact same work, as well as a bank of Redis servers too. So that was our first thing. So if you want more detail on that, like I talk for like 40 minutes in that talk. The next thing was like Nginx is awesome. What's this Lua thing? Well, Lua is a language that embeds really well in other languages or other processes. So Nginx and both Redis, now you can just run Lua scripts. And Lua is almost Pythonic, almost. And so it was really easy for us to just start building features in there. I'm going to just show an example of one of those in a sec. That link is not to discuss code. That's to me playing with it to see if it would work. But that is basically is an Nginx box that you can just run like anything that you reverse proxy to. So anything that listens to HTTP. And it's going to do persona authentication checking in the middle. And that's all done in the web server. So it's not even going to, the request will never even hit the back end if you don't authenticate on the right domain. And the whole point of that was to like say, hey, like designers, they want to do cool things too, but they don't know how to do authentication. I don't want to trust them with figuring out how OAuth works. So I did it. And then the last thing is Go. So I've been talking about this real-time thing I made. Well, eventually, it was seeing like 10,000 concurrent events on our back end. So we just kind of, there was the front end that we replaced with Nginx already. Then the backstream processes of that were just seeing so much concurrency of just messages that we had to broadcast to the internet that we ended up rewriting the thing in Go. And that works, that's in production right now. And that was not me, that was someone else that had a super fun time playing with that. But it worked really great, and we got it out in 1 week because it was isolated and separate. It was great. So here's an example of Lua, and it is not indentation sensitive, apparently. That is an error. But yeah, so what this is doing is this is code that we are running in production, I think. And it's a thumbnail service. So if you hit our servers and you see a thumbnail of something, it was fetched with this code. So this will, Nginx will actually spawn a brand new thread for every single request. So they're super highly concurrent because they're all individual. And because they're their own threads, they also have like code isolation in here. So that means that two concurrent requests aren't going to be able to even know each other exists. You're not like in Flask, there's all this stashing of globals and stuff. And so that's just not even globals and thread locals. That's just not even a concern with Lua. So this is just going to hit embedly, it's going to get the image, and it's going to return the thumbnail right there, or a URL to the thumbnail. So this is just one example of, this was a couple servers that were previously doing this in Python, and we replaced it with a server that does it in, it's actually the Nginx process is doing other stuff too. It's so much more efficient. But again, we love Python. And Python is really great for a lot of things, especially when I was saying isolation and iteration speed. If you don't need that, like, last 2% performance, we stick with it. I keep on saying like isolate failures, but I really want to say it's like it also is a platform for success. It really allows someone to iterate faster. So yeah. So what do we do for writing Python services? Well, we have a strong tradition at Disqus of trying it new ways all of the time. So the first thing we tried was just like a cron job of a Python script. So just if name equals main, then do stuff. We also just have like simple WSGI servers. Like, oh, we just need to serve like one thing. And then we also have XML RPC servers, which is the worst thing ever. But it actually works really well for this exact one use case where it's serving a proxy object. So we can, in development, it's the exact same code and we can access production data, but we can filter out any write commands. So it's just read-only access, and we can enforce that by having a proxy server. But it works great for one deploy. And then you have to like do it again. And that's usually you nagging the ops guy say, oh, can you SSH in and like check out and rerun that process and kill it? And oh, it didn't work that time? Shoot, okay, I didn't test it well. So yeah, so lessons from that is just that consistency across those services was horrible, and we want it. We want people to load config from the same location. We use Zookeeper for config. You should do that. Oh, you don't want to write this code for Zookeeper? Well, you're the one writing your own little service. You have to do it. Simplicity is good because then anyone can just pick it up and run with it without having to understand your own little world. Modularity is good because everyone wants to do the same config reading, right? So we should maybe make that a module or something. And copy paste is bad. So don't just copy that guy's config loading code because you're going to change it and then it's going to be different and that's going to be bad because yes, I know you're going to change it. I know you say you're not going to. You will. And then not bugging ops is the best because they are always too busy for me. So what did I do? We wrote some code called Disqus service. And we actually wrote two things called Disqus service. It's a little confusing. The first thing called Disqus service is this code. Shortly afterwards, the thing called Disqus service works with this code to do auto deployments. So we basically made an API in Jenkins where once your code review happens, if your code's accepted and Jenkins runs the tests and they pass, Jenkins will auto deploy it. As long as you use setup.py correctly, as long as you know your setup.py tests, setup.py install. Basically, we just said setup.py is our API. And so that was just like a killer decision to make it so ops doesn't care anymore. We just have to say, oh yeah, conforms to the API. They're like, okay, push the button. Now we have our own new little pipeline that deploys the service. So what is Disqus service? Well, the goals were that we want to be consistent with respect to config, with respect to switches. Switches for us are how do you A/B test, right? So we're going to have how do we report on that information and how do you get whether or not you should be doing an A/B test. We want consistent logging and error reporting. We use a program called Sentry at Disqus, which was written at Disqus and is also available at getsentry.com if you want to just install it. One of our guys does that now instead. Record stats, we use statsd, but we want to be reporting the same stats everywhere, as well as just other internal systems. So, and most importantly, it should be easy to run. So the first thing in the Disqus service is the @service decorator. It's the equivalent to the kind of like @main or if main option, and it looks like this. What is all this indentation? All right, so, man, it's not real code. This is in rich text format. So, yeah, pigments right here. Okay, so I'm importing the service decorator, and then I decorate the my function world, and it prints hello world. And the way I would run this is with the helper program called toil. So you just say toil run hello.world. That is a Python path to the object in the Python in the hello module, and it will run it. And it will also do lots of other stuff for you. But as far as an application developer is concerned, they just care about what's inside the function. But sometimes you're like me and you're like, I care about more. So I gave more. So there's a class called service, and it has more decorators that you can use. The handler decorator is going to give you access to, that's how you define what's the main method in a class. And then there's some lifecycle handling decorators that execute as hooks around config, setup, or update config. So a little bit slightly more complicated example. This one is going to do, so we see we're inheriting from service, and then we have the handler decorator saying, oh, world, that's what you're going to run when someone does the run from the command line. And then post config. So this, in the background, the service is going to go, it's going to load some config files from Zookeeper. It's going to load them from the environment, from environment variables. And it's going to also load them from config files, both default config files that have assumed position in the module, as well as overrides from local config files. And so that's all going to happen in the background. And then after all of that happens, I'm going to get, oh, hey, I wanted to get the Redis host and the Redis port. I'm going to just set that up on a little instance variable. And then I can access that in my main method up there. And it's run in the exact same way as it was previously. When we were working on this, we kind of found that there were some things we were doing really quite a lot. So we were making a lot of web services. So we just kind of made a Flask service mixin, and that's going to just allow you to get all of that config in the same consistent way, but it's also going to act just like a Flask app. G-Event service, that's basically, I love G-Event personally. It's great for concurrent I/O at pretty reasonable and high levels. Redis service, that's just is basically going to give you that Redis attribute, just like you saw here. It does basically this. Kafka service, Kafka is a queue we use internally, and Django ORM service. This doesn't currently support actually using Django views or anything, but we use Django a lot, like I said previously, and we have a lot of institutional knowledge around how that ORM works. So we really wanted to support the Django database as an option for these services. So here's just like one example of real-life Disqus code. This is the shell class. So this is for when you're developing something using Disqus service. It's just going to dump you right into an IPython shell, almost identical to, in Django, a manage.py shell would. So it's going to load service context, and you're going to have access to, since you're inside of the shell function, you even have access to the self variable, so you can, self.redis and run forward with that and do cool stuff. And you can see I use the Redis mixin here to get access to Redis. So I've mentioned,
Go back and explain why that's important.
What's important? Which part?
Why is this slide important? What is it doing that would be hard to do without this?
Oh, so great question. So the question was, what is this doing that's difficult to do otherwise? So if you're just going to load a Python, or like if you want to just load a IPython shell or something, you can totally do that. But what the service framework does is it is going to connect to all those other services like Kazoo, I'm sorry, not Kazoo, Zookeeper, and other things. So what this is doing is this is doing all that bootstrap code such that when you dump into the shell, you are connected and have access to all those services. So it's already connected to databases. It's already connected to, so like in Django's manage.py, you can just start accessing objects, right? You can say like my models.objects.all because it's connected to the database. This is doing the similar work, but using the Disqus service framework. I really wanted to show more examples about mixins because I think they're really awesome as a way to organize code. So I'm gonna need you to use your imaginations for a second. These are slides from my previous talk. So they're gonna talk about pipelines because I was talking about data pipelines, not services. So pretend that it says service instead of pipeline, but the concept's really similar. So in the pipeline example, the pipeline had a life cycle. It has 4 stages where basically you're going to say, hey, I want to parse this data, I want to compute some data, I want to publish that data, and then I want to handle an incoming message somehow. And so just like the services, where I had that Redis service doing just one specific thing, these are now a couple examples of very specific things that you can do in this pipeline. So the first one is just, I'm going to parse JSON input, right? And it's only doing the parse step. And anonymize is only doing the compute step. It's in case the NSA is listening, we want to just return no data. Then we have the compute step. This is the super secure one, so we're going to rot 13 that data. Super secure. And then we're going to publish to HTTP, a web URL, or a file or something. And that's an append. Cool. So then when you want to actually use these, you just kind of pick and choose, because as long as you're not using the same stage twice, they're going to mix in really well. You're not going to have any, this is technically multiple inheritance, but because they were specifically designed to not overlap with each other, they work really well like this. So you can just say, oh, I made a JSON parsing anonymizing HTTP publishing pipeline, or a JSON parsing super secure pipeline to a file, etc. And so that's cool because I didn't have to copy paste anything. It's really modular. As you add more, you can mix them together really well. But the best part is the testing story, because the tests look just like those mix-ins. So assuming I had tests of these names to correspond back to these original things, you only have to test one thing per class really well. If you were to do this by either copy pasting code, or if you were to make each of these pipelines individually, now your testing is also getting replicated out. So I just think that it's the best paradigm ever, because your tests are super, super straightforward, and they're simple because they do each one thing. It's just about having well-defined interfaces. There's no real good segue here because this is a beta test talk, so I'd like to thank everyone here for being a part of this. I'm giving this talk at a later conference. But yeah, so we have lots of open source stuff because I've mentioned several open source things that we use, like Nginx, like Django. We've contributed back to both of those, as well as several other things. This is just a list of things I briefly mentioned, some of them not. But Sentry is what we use to get errors in. Check it out. It's the best thing ever if you haven't done it. It's going to tell you what exceptions are trending in your system. Nidus is how we manage ring-based Redis connections. Django mail views is something that we released recently. It's sending email, like cool formatted ones that look pretty from Django. Gargoyle is how we've done switches, A/B testing previously. And we're just starting to try out our rewrite of it called Gutter, which is just like super powerful that you get to like write awesome things. And it works for more than just Django. Gargoyle is Django only. Gutter works in everything. So if you want to check that out, go to our GitHub page. And unfortunately, Disqus service is not open source yet, but I've talked to a lot of people that are solving the exact same problems. And I want feedback. Should we open source it? Would people actually use it? Would anyone like raise your hands if you would actually use this? All right, like maybe. Okay, cool. Like some people. So yeah. So if this was interesting to you, we're hiring, and I run meetups. I run a meetup called ArchCamp, which is more architecture centric. We talk a lot more about ways to solve problems at scale, less about any particular language. So if you want to hear more about those Nginx scaling solutions, or our next one is going to be on segmenting data and how to do recommendations. I'm building an ad server now, so that's near to my heart. I also run the Disqus meetup, which is hackathons and happy hours. So join those. So just a quick recap. What did I just talk about? We love Python, but not everything we do is in Python, because sometimes other tools are better for the jobs. Not everything is a nail, and we have more than just a hammer. Let's see. Services are awesome, but they have some problems, and I've got some questions about those next, if you have answers. Mix-ins are the best ever, especially for testing. And I don't have all the answers. So how do you guys run services? Like, how did you end up segregating your code? I like queues. I like stream-oriented data, but do people here like RPC? Just everyone thinks a website? Like, what do you do? What do you do? What do you do for super high concurrency? Because I do this all the time too. But I like writing Python more than I like writing Lua. So if there's an answer there. Do you guys like lint or anything in your code before you commit it? And if you do, how do you filter on like, pdb.setTrace is technically going to be PEP 8 compliant, but you still don't want it in your code. So if you found a solution to that, like, can I have it? That'd be great. And then the last thing is, so dev doesn't equal production, or does it? Like, when we're using manage.py run server, sometimes that has different behavior than when we run it with uWSGI. So do you guys just like say, we'll probably work? Because that's what we do. I would really like to be better than, it'll probably work the same, because I've seen it not work the same. So, yeah, so that's my questions for you, and that's all I have. So thank you for being my beta testers. I hope it was good.